Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from group 5 and today we will present about the controlling ash or combustion residue in the recovery boiler. Okay, before we begin, I would like to introduce our members. The first one is of course me. My name is Muhammad Wisnoe W and I will be the moderator. And then the presenters is Nela, Ruth, Dewi Siregar. Next is Glorya Jureland, Muhammad Gilang, Tanisha Nabiha, and the last one is Annisa Maharani. Table of content: 1. Definition of recovery boiler. 2. Definition of residual combustion ash. 3. Working principle ESP. And 4 ESP components. Okay, before we start the first material, let's watch a video about craft recovery boiler precipitator.
ESPs work on the principle that opposites attract to each other. In plate wire precipitators, exhaust gas flows through parallel plates of sheet metal. Between each row of plates hangs a row of high-voltage electrodes. This design allows many flow lanes operating in parallel. Therefore, they are well suited to handle large volumes of exhaust gas. As the exhaust gas passes between the plates, high voltage applied to the electrodes cause the particulate in the gas stream to become negatively charged. The negatively charged particulate is attracted to the positively charged plates and is collected on the plates. Wrappers shake loose particulate from the plates, which falls into collection hoppers for removal.
Okay, the first material, the definition of recovery boiler, will be explained by me. What is recovery boiler? Recovery boiler, or RB, serves to purify the chemical compounds of soda in the black liquor resulting from the cooking of digester pulp making, and at the same time to generate a high pressure steam used as a turbine drive. The combustion of heavy black liquor that occurs in the recovery boiler produces a thick greenish gray liquid called smell. This smell will be mixed with weak white liquor or WWL into green liquor or GL, then processed again in the recrystallizing or RC unit into white liquor or WL. The WL is reused as food cooking material in the pulp making digester. In other words, the recovery boiler is a part of chemical recovery. For more details can be seen in the following figure. Okay, the next material is residual combustion ash. Will be explained by Nela, Ruth, Dewi Siregar.
Okay, I will explain about residual combustion ash. Ash and combustion gases called flue gas still contain high heat energy values. So the later this flue gas will be cycled in by a device called an induced draft fan. When the flue gas passes within the boiler pipes, so that the water inside the piping slowly becomes hot, heat transfer and turns into high pressure steam. The remaining combustion in the form of ash and gas still contains some chemical particles. Later, the ash resulting from this combustion will be captured by a toll collet, an electrostatic precipitator ESP. So, the later the ash will be separated from the gas and collected again, not released into the atmosphere, and collected using a conveyor to be sent back to the mixing tank to be used again in the next combustion process. will the chemical particles still contained in the combustion air will be captured in the process. In the next combustion process, will the chemical particles still contained in the combustion air will be captured in the scrubber using warm water spray, and then the chemical substances will be sent back to the dissolving tank as mixing material for making GL. So the remaining air released through the stack into the atmosphere is in a safe condition for life around.
An electrostatic precipitator, in short ESP, removes carbon and dust particles from a gas stream by using electrical energy to charge particles either positively or negatively. The charged particles are then attracted to collector plates carrying the opposite charge. The collected particles may be removed from the collector plates as dry material, dry ESPs, or they can be washed from the plates with water, wet ESPs. Electrostatic precipitators are capable of collection efficiencies greater than 99%. An ESP is primarily made up of the following four components: gas distribution plates, discharge electrodes, collection surfaces, either plates or pipes, and wrappers. The gas distribution plates consist of several perforated plates, which help maintain proper flow distribution of the entering gas stream. The discharge electrodes are divided into fields. Most ESPs have 3 or 4 fields in series. However, very large units may have as many as 14 fields in series. Discharge electrodes are energized by transformer, rectifier set, and power supply. The energized electrodes create ions that collide with particles and apply the electrical charge to the particles contained in the incoming gas stream. The collection plates, or pipes, provide the collection surfaces for the charged particulate matter. The wrapping system is responsible for removing the collected particulate matter from the collection surfaces.
Okay, thanks Nela. The next material is electrostatic precipitator, will be explained by Glorya Jureland.
Okay, now I want to explain about electrostatic precipitator or ESP. As explained earlier that the air or excess gas from production must be processed first. This is useful to prevent air pollution that may occur. The tools that commonly used in industry name is ESP. ESP or electrostatic precipitator is a tool as an ash collection and serves to reduce pollution caused by burning coal in the furnace. So ESP is a tool to process the air combustion ash. Electrostatic precipitator, which is installed in the chimney system. The system is used to capture fly ash from combustion that is carried away in the smoke coming from the boiler. The technique used is by trapping fine particles using high voltage electricity. Coal that is burning will be produced burning carbon dioxide, sulfur dioxide, and nitrogen oxides. These gases are removed from the boiler. Heavy ash is dropped to the bottom of the boiler and enters the silo for disposal. Fly ash is carried away by the hot gases in the boiler. This fly ash is captured by an electrostatic precipitator before the flue gas flies into the air through the chimney. ESP functions as an air filter that filters or captures 99.4% of fly gas. An ESP consists of several positive and negative electrodes. Fines that are fed a DC voltage source of maximum 90 kilovolt DC with a current of 500 milliampere. By being electrified on the electrofines, a corona will occur which gives a negative charge to the ash. It can be said the S which has negative ions will be attracted and attached to the positively charged plate. So what about the work principle of ESP? The first one is charging of particles. Discharged electrodes are electrically charged inside the electrostatic precipitator. An electric field very close to the discharged electrodes charge the fly as particles. A corona discharge usually serves as an indicator of this electric field. A unipolar ion source that moving toward the collecting electrode is provided by the corona discharge. The unipolar space charge fills the empty space that exists between the discharge and the collecting electrodes. This space is crossed by fly ash particles, which will absorb the ions present and becoming highly charged as a result.
Alright, thanks to Glorya. The next material is work principle ESP number 2 and number 3. Will be explained by Muhammad Gilang.
Okay, my name is Muhammad Gilang. I will explain to work principle ESP. 2. Particle collecting. The positively charged discharged electrode will attract the as particle to the collecting plate. After the discharge electrode has negatively charged, the applied a negative charge to the fly as particle so that clean as free gas air that comes out of the electrostatic precipitator is clean as free gas, flue gas. Gas containing particle enter the XP collector chamber. In this chamber, there are suction electrodes and collection electrodes which are installed in opposite direction. The suction electrode is given a high positive electric charge, while the collecting electrodes is given a high negative electric charge. When the gas process through the collector chamber, the particle contained in the gas will be ionized or electrically charged by the surrounding electric field. Particle with a positive electrical charge will be attracted toward the negatively charged collecting electrode, while negatively charged particle will be attracted toward the positively charged suction electrode. Because the collecting electrode has a stronger electric field than the suction electrode, the collecting electrode has a stronger electric field than the suction electrode. The ionized particle tend to be attracted to the collecting electrode and stick to its surface. 3. Transporting of collected material. After some time, the collection and discharge electrodes will be filled with particle. A ripper is used to remove this particle. The ripper will vibrate these two electrons while they are running, causing the particle attached to them to fall to the bottom of the electrostatic precipitator or hopper. The vacuum blower will draw the ash into the ash silo from the hopper. The ripper hits the particle one by one, taking turns at a predetermined time. Particles that have collected on the collection electrode then need to be transported or disposed of regularly to maintain collection efficiency. This transport process usually involves a cleaning or flushing mechanism on the collecting electrode. One commonly used method is to use a vibrating system or automatic cleaning system that displaces or kicks collected particles from the electrode surface. Lost particles can be collected and directed to a suitable disposal site.
Okay, thanks to Gilang. Before we continue the material, let's watch a video about ESP components.
Hello friends, welcome back to my channel BOE Tutorials. In this video we will discuss about components of electrostatic precipitator. In this video we will discuss about electrodes, 440 volt 50 Hz 3-phase supply, high voltage transformer, rectifier and hopper. Electrostatic precipitators are mandatory nowadays in thermal power plants and other power plants where there is discharge of flue gases. With ever increasing concern about environmental pollution and the need to reduce it, electrostatic precipitators have become a necessary. Electrostatic precipitator use the high intensity electric field to ionize the dust particles in the air stream, and then the dust particles get collected by opposite charge collectors. The dust particles once collected are removed from the collector plates periodically by hammering the collectors. Component of electrostatic precipitators. Here is a basic diagram of an electrostatic precipitator. Here you can see there is an AC supply which is fed to a control cabinet. The voltage is stepped up by using high voltage step-up transformer and then rectified by diodes. Once the AC is converted to DC, it is fed to the discharge electrode. The flue gases pass through the discharge electrodes and get ionized. The collector electrodes, which has a porosity opposite to that the ions, attract the ions. By hammering the collector electrodes, the dust particles are separated from the collector electrodes and is collected by the hopper. The various components in an electrostatic precipitators are electrodes, 440 volt 50 Hz 3-phase supply, high voltage transformer, rectifier, hopper and insulators. Electrodes. Discharge electrodes are made up of tubes containing welded and annealed copper wire of small diameter. The wires hang vertically and can produce a high amount of corona discharge. The main function is to generate a high intensity electrical field and ionize the particle in the flue gas. Collecting electrodes are made of sheet metal. They attract the particulate matter. Transformer rectifier unit. High voltage DC is required to charge the discharge electrodes to produce the corona effect. To that, first the voltage is first set up using a high voltage transformer. Then the AC supply is changed into DC. The DC supply is then fed to the discharge electrodes. Hopper. Hopper is a large paramedical shaped container that collect the particulate matter. They are made up of steel. The dust collected in the collecting electrodes get transferred into hopper. When wrapper coiled, dislodge the particle from the electrodes. The hopper collects the dust particle. Once the hopper reaches maximum capacity, the dust is expelled out through an opening in the bottom vibrator and installed on the outer wall to release the particulate matter.
Next is ESP components, will be explained by Tanisha Nabiha.
Okay, my name is Tanisha Nabiha. I will explain about electrostatic precipitator components. The first is casing. Electrostatic precipitator casings are usually made from durable materials such as ASTM A36 steel or other similar material. This casing is made airtight so that exhaust gas from combustion does not leak. In the casing, there is an expansion room. A heat-resistant insulator is installed, and there is a door for people to enter and exit to carry out maintenance on the electrostatic precipitator so that it is always in top condition. The second one is discharge electrode. The discharge electrode used to attract dust or ash is a combination of a pipe with a corded steel wire attached to a network of poly electrodes. The network of attractor electrodes is arranged to provide a distance between the attractor electrodes and the collector electrodes. The discharge electrode works to attract dust or ash along with the air that enters the dust collector electrodes. The next, collecting electrode. The collecting electrode used to collect dust or ash consists of a row of square steel. A series is installed at the top and bottom of the collecting electrode. This series is intended to maintain the balance of strength of the collected iron plate. It is a plate that is positively charged and has the function of capturing dust that has been given a negative charge by the discharge electron. This arrest is based on electrostatic force. Next, wrapper. It is a component that is used to heat the collecting electrode so that the dust collected on the collecting electrode will fall down. Wrapper will work sequentially depending on the setting given. The wrapper collector electrode operates more because of the dust or ash collects. Wrapper operation can be stopped by gradually reducing the speed and number of beats. Well, then about ESP components will be continued by my friends.
Thanks, Tanisha. And then the next material is ESP component number 5, 6, 7, 8, 9, and 10 will be explained by Annisa Maharani.
Hello, my name is Annisa Maharani. I will explain the next ESP components. The next is hopper. The hopper is a component that functions to check dust that falls after the wrapping process on the discharge electrode. The hopper is made of iron which is placed under the electrostatic precipitator so that the container has a room large enough to accommodate the dust or ash collected for 12 hours. The container must not be filled until it's full because the level indicator will automatically give a warning in the control room. If ash accumulates in the container, it will be filtered using a sensor and will be removed by operating a blower. The ash that has been emitted by the transmitter will be transported
by a transport truck and disposed of to the final disposal, namely in the form of a large pit made specifically to accumulate ash. The next is handling device or HD. Handling device is a component of the electrostatic precipitator which function to release dust or ash or particles that have collected in the hopper. This component is the area with a strongest electric field in the electrostatic precipitator. The next is insulator room. The insulator room functions to filter dust or ash that enters the electrode discharge to attract dust or ash. The insulator room is inside the towing electrode. The next is direct current source or DC supply. The direct current source comes from a battery which is used to supply electric current to the dust or ash collector and collector electrode. When the dust or ash will stick to this electrode because the electrode has turned into an electric magnetic field. The next is transmitter. The transmitter is a blower device which is used to blow dust or ash that enters the hopper so that there is no accumulation of dust or ash on the hopper. The last is transformer rectifier. Transformer rectifier is a component in the electrostatic precipitator which functions as the overall electricity supplier in the electrostatic precipitator system. The component is made to withstand high current voltage or electrical surges.
Okay, thanks to Annisa Maharani. Let's watch the last video about electrostatic precipitator or ESP technical video.
ESP, electrostatic precipitator, is a very advanced air pollution equipment that works on the principle of electrostatic precipitation. It can capture even the finest of dusts. It has a very high efficiency, and it can achieve emission levels of less than 10 mg per nm cube. It has very low pressure drop of less than 20 mm water column. Principle of ESP. When flue gas with dust particles is passed through a high voltage of electrostatic fields, electrons are released. The high voltage current is passed through the anodes. The leakage of current from the anodes is called corona. These electrons charge the dust particles negatively. The negatively charged particles sticks to the cathode. This process is called collection. The flue gas along with suspended particle enter the ESP through the CFD optimized splitter and GD screen, which evenly distribute the flue gas across the entire ESP. The emitting electrodes in the center of gas flow is maintained at high voltage. The entrained particles are given an electrical charge when they pass through the high voltage electric field. This forces the charged particles to migrate towards the collecting electrodes. The collected particles are then dislodged from the electrodes to the hopper by means of wrapping. The hopper is evacuated continuously through the dust handling systems. We help to protect the environment. For a greener tomorrow. Unicon. Delivering technology and services.
Maybe that's all the presentation and the material we have. Hopefully the presentation will give benefit for us. Thank you for your attention. See you later. Wassalamualaikum warahmatullahi wabarakatuh.